First lesson today, just functions. If we're going to take a course called Advanced Functions, we better start off with what's a function? You got this note in front of you? It's all matching up, making sense? Yeah? Here's the complete description about what a function is. It's simpler than you think what a function is. A function is a rule that gives a single output for every valid input. So all a function does is you give it a number, it spits out a number. The simplest function you've seen so far would be like y equals mx plus b. You plug in a number like 3, it punches back out a number like 7. That's all a function is. Now, specifically though, this is the important part. For every x value, there's only one y value. You only get one answer out. The reason we restrict ourselves to functions in high school is because most of the math you'll do in high school will involve functions. You'll get one input gives one output. For instance, if you're in chemistry class and you give one time, there should be one temperature. You wouldn't find two different temperatures for one time. In physics, for one time, you'd have one height. In economics, for one time, you'd have one profit. You wouldn't say, oh, the profit is this or this. You don't get two different answers. Now, your brain might be flying ahead to going, well, it is possible to get two different answers. We've had questions in high school where there was two possible answers. I know. We don't call those functions, though. Yeah? So we're trying to restrict ourselves to those kind of things. Expanding past functions, can we do that easily? Yeah, after we get functions down pat. And this is why we're trying to get functions down pat. Grade 11, functions. Grade 12, advanced functions. We're really trying to get great at functions. It goes back even farther. By the end of this chapter, you'll find out that grade 9 could have been called basic functions. Grade 10 could have been called a little less basic functions. And then 11 is functions, and now advanced functions. It's functions the whole time. The whole thing's about functions. So here, function or not. This is actually a good way to write out rules. You can really see what's going on. You don't need an equation. You don't need a graph. You don't need any of those things. You just go, okay, if your input is 1, output is 1. If your input is 2, output is 4. Input is 3, output is 9. Input is 4, output is 16. Maybe you can see what's happening. Everything's just got squared here. The question is it a function? Does each x value have only one y value? It's actually, I think, the more confusing example than when something's not a function, because you're like, well, I think so. And you just got to look and go, okay, 1 becomes 1, 2 becomes 4, 3 becomes 9, 4 becomes 16. Yeah, every x value became exactly one y value. Here's one that's not a function. If that confused you, take a look at one that's not a function. In this one, 2 becomes 1, 7 becomes 5, 8 becomes 6, and 2 becomes 4. Where does this thing fail from being a function? Which x value fails? The 2, yeah. Here it says 2 gets mapped to 1, but also 2 gets mapped to 4. It's a perfectly legitimate mathematical thing. We're not saying this can't happen. What we're saying is, when it does happen, we won't call that a function. How about this one? Negative 7, 1, negative 3, 5, 4, 5, and 6, 1. They're trying to fool you here. Because this thing looks like it might fail, but it doesn't. Negative 7 goes to 1. Negative 3 goes to 5, 4 goes to 5, and 6 goes to 1. See, each x value goes to only one y value. They try and fool you here to say, ooh, there's 2 5s there. You can have the same y value twice. Yeah? Think about in chemistry. It wouldn't surprise you that at time negative 3, whatever that means, 3 minutes ago, it was temperature 5 degrees, and 4 minutes from now, it's going to be temperature 5 degrees. That wouldn't catch you off guard. You'd be like, yeah, it can be 5 degrees 2 different times. What can't happen is you can't at time 2 be 1 degrees, and at time 2 also be 4 degrees. You're like, well, how can you be 2 different temperatures at the same time? Functions are like real life, almost. Functions are like what really happens for most real life situations. Any questions on that first slide? Okay. Usually, I go, any questions? And I say, does anyone need more time there? I'm going to leave that out. But don't let me rush you. You can treat me like you treat your iPad or your phone. If I go too fast, just use your hand. Just wipe it through the air, swipe it like this way, and I'll swipe back to the previous slide. Won't bother me at all, okay? And then I can save some words at the end of every slide. I'll just say, any questions? I'll look around, and then if I switch the slide, you just reach up and go, no, go back. More function or not? Now using a table of values. 1, 5, 1, 7, 2, 3, 7, 8, 9, 12. Is it a function? Does every x? No. I'm seeing some no's now. Which x value fails the test? 1. 1 can't go to 5 and only go to 7 at the same time. Okay. Most classes don't like the individual answer anymore. We've outgrown that in high schools. We can do individual answers. Most people just, several people shout out the answer at the same time. I love that too. Or you can raise your hand and do it, whatever. What I promise is I won't call on you unless you raise your hand. If I ever do that, it was an accident. Sometimes the mask messes me up. Yeah? So feel free to out loud say an answer. Feel free to raise your hand, whatever. Don't care. Not a function. 1 can't go to 5 and 1 can't go to 7 at the same time. You can, again, I keep going back to chemistry or to biology. Oh, there's a lot of biology people. I'll use that. At time 1, the population can't be 5, and time 1, the population will also be 7. You know, that can't happen. How about this one? Negative 2, 2, negative 1, 5, 0, 7, 1, 5, 2, 2. Is it a function? Not a function? This one passes the test. Even though multiple y values happen like this, yes, you can have population 5 2 different times. What you can't have is 2 different populations at one time. This is as tricky as I could think of to be with a table of values. Is this a function? At first glance, I'm going to take the no side, and I'm wrong. The no side is, well, look at 2 different x values of 5. Can't be a function. You have 2 different times of x. What is it about the y values that makes it goes, no, no. It's actually okay here to have 2 different x's. The y values are the same. 5 to 4, 5 to 4. That's not weird, even though 5 happens 2 different times there. Questions there? Does this PowerPoint seem familiar to any of you? I believe most of it's used in grade 11 at some point. If you look at this and go, these examples seem familiar, a part of my brain somewhere. Yeah, because we use this PowerPoint almost exactly the same. It's changed slightly in grade 11. More function or not? Ooh, the graph. It's easier to see in a graph. We'll get to, maybe you're remembering something about finding functions on a graph. We'll get to it in just a second. Each x value has exactly one y value. 1 goes to 5 and there's no other y value it goes to. 2 goes to 6 and there's no other y value. 3 goes to 7, there's no other y value. 4 goes to 8, this is a function. This one's not a function. Which x value fails the test? 3, you can see. You just look straight up like this, and I'm moving towards this thing you might know from previous grades, which is just that you look up and you go, okay, at 3, there's an 8 and also a 9. That can happen in math. You can build a table of values like this when you're taking measurements in chemistry or biology class. You know, it can happen. We just don't call it a function when that happens. Oh, look. This is the function we're going to analyze later today. It's called absolute value. 1-04, you can see on the board there. I'm going to be teaching absolute value later today. It looks like this. Not too complicated. Yeah? Absolute value it's called. Whatever. You don't care what it's called right now. Is it a function? Is there any x value that has more than one y value? No, every time, every x value has exactly one y value. That's a function. But take a look at this one. So if you're really still having trouble with function, these 2 examples might tell the whole story. Here, every x value has exactly one y value. But here, say take an x value of 2, you can have y value 2 or negative 2. This is a legitimate mathematical thing. This can come up in math. It's fine. We just don't call it a function, that's all. Any questions there? So, when we look at a graph, how can we tell if it represents a function? The graph represents a function if for every value of x, there's only one y. That's restating what I said before. But did you see the vertical line test in previous grades? Maybe right now you're like, I remember seeing vertical line test. I don't know what it was for. That's what I've been using here is a vertical line test. If you can draw a vertical line straight up and hit the graph twice, it's not a function. You know, it's a nice, easy way. Nobody really ever draws the graph. They just picture it in their mind. They look and they go, okay, is there a vertical line that would hit this twice? And no, there's not. It actually goes through it here. See, there's a vertical line, doesn't hit it twice. There's a vertical line, doesn't hit it twice. So as long as it doesn't hit it twice, it's a function. What about a parabola this way? Well, it fails everywhere. Every time you draw a vertical line, it hits the function twice. That's not really saying anything different than I was in the previous slides. It just gives you an extra weapon to use to decide if something's a function or not. Questions there? I'm going to try and look up that break schedule in between examples here to make sure you get your break this morning. Okay. If that's all pretty straightforward, this is one of the main ideas of this chapter, is that there's a list of functions that by this point you're supposed to know. And if you don't know them, we're going to take this week to make sure we get to know them. There's a list of functions that you're supposed to be able to look at and either come up with a graph or in your brain be able to picture them and get the answers. Y equals x squared is first on that list. Y equals x squared is one you're supposed to, when I say y equals x squared, a visualization of y equals x squared is supposed to come up in your head, and you're supposed to be able to go, oh, I know whether this is a function or not. Now, what I say to people right now and through all this chapter is, anytime you get a function you don't know and you're not sure how to answer it, then graph it. Whether you want to know whether it's a function, whether you want to know its domain and range, which we're going to do in the next lesson, any of those things, first graph it. Is there a way to do it without graphing it? Yeah, there could be. We could get that good, but that's not really the goal of this course. This course doesn't set the goal of being able to just do these in your head. But don't feel bad if you can. If you can look at y equals x squared and go, I know whether it's a function or not. I don't have to draw it. That's fine. Know that if you have trouble with one, just graph it and then you can get whether it's a function or not. So y equals x squared, this is the image that's supposed to pop into your head. If it doesn't, well, we really need that. Yeah, you can put that on the list for this week. By Thursday's test, we really need to be able to image y equals x squared. And I'm going to do transformations tomorrow, the lesson transformations, where I'm going to do all sorts of transformations on the functions you've seen before, and you get lots of chances to practice knowing all the different functions that you're supposed to know at this point. And if you don't, that's fine. We're using this week to learn them. Do you need a graph to determine this? No, there'd be a way to go, listen, any x value I think of, say 7, if I square it, I'm only going to get one answer. I'm not going to get two different answers. So it's a function. Yes, there's ways to think those out, but I don't really think that's the goal of this course. The goal is to say, let's get the graph. In fact, this whole course, if this course was to have a different name than advanced functions, its other name would be graphing. We're going to learn how to take all these functions and put them on a graph so we can visualize what's going on. What about y squared equals x? Okay, well, if y equals x squared is this parabola, then y squared equals x has reversed the roles of x and y, and you're going to get, they'll do it algebraically. You're going to get this parabola. Let me draw it on here for you. Pointer options. I want a good color here. We'll do yellow here. There's x equals y squared would look like that. Just reversing the roles of x and y. Instead of having a parabola straight up down, you got a parabola that's going this way. It's not a function. And you're like, oh, we haven't seen that one before. That's right, because we're doing functions here. We won't do too much with these. There's another way to look at this, which is algebraically saying, if you choose an x value of 4, then there's two different y values. Remember the plus or minus stuff that pops out of quadratics? When you're doing like quadratic formula or you're solving something that's squared, you always get this plus and minus out of it. That's what we're talking about here, is that when you have a plus or minus like that, and you get two possible answers, we're not talking about a function anymore. These mapping diagrams are really handy to be able to really look at what's happening with a function. And you'll see a few of those in the homework where they say, okay, instead of a table of values here, you can make a table of values out of this. 1, 5, 2, 5, 3, 5. That's fine. But this really has a nice visualization to it. What's going on? 1 turns into 5, 2 turns into 5, and 3 turns into 5. And because each x value is only going to one y value, this thing is a function. That can be confusing, but when I do the other one, you go, oh, okay, I get it now. Here's one that's not a function. Which x value, which input here, causes this to fail and not be a function? There's something very sort of obvious once you see it that shows which of these x values is doing something bad here. 10, yeah, 10 does not pass because 10's going to 3, but 10's also going to 9. You see, all the different x values going to one y value, that's fine. But each individual x value can't go to two different things. Again, go back to your biology type example. On day 10, you can't have population 3 and population 9. It's okay if on every day your population was 5. That's legitimate, but you can't have two different populations on a certain day or a certain time. This one's fine as well, and you can just look over here. In fact, I don't need to look over there at all. I can just look and go, 21's going to one thing, 22's going to one thing, 48's going to one thing, function. Questions there? Okay, function notation. As it turns out, you've been doing functions the whole time. Grade 9, grade 10, grade 11, it was all functions. But sometimes this notation will be easier to use. And when you first see it, it seems weird. Because a grade 9 teacher, like me, I might have said this to you in a grade 9 class. I might have said, when there's two letters beside each other, that means multiply. And I knew I was lying, but it was all that we needed right there. Then you move forward. Until you use function notation, when this means f at x. There's a whole story here about what's going on. It means if you want to know the y value, take the x and sub it in over here, and the output that we get over here will be the function value, will be the y value. This actually is straight from grade 9. This is y equals mx plus b. But f at x represents what you get when you plug something into the function. Some visualizations are needed. I'm going to come back to this slide in a minute. I see frowns. That's good. I like the frowns. We're going to come back to this slide in just a minute after we look at a function as a machine. A good answer. You get home tonight and say, what did you study today? You say, oh, we studied functions. Your mom or dad says, what's a function? You say, it's a machine. That's what a function is. It's a machine. And what happens with the machine is, there's f the machine. Some x value is going to come along, and you're going to plug it in to the function. And then the function is going to think about it for a little while, do some calculations, square the number, add 7, multiply it by 30, whatever the function tells you to do, and then you're going to get an answer out, and that answer we call f at x. So you put x in, you get f at x out. Lots of times, instead, we'll call this y, and I'll put that right here. Maybe you should put that in there. I'll put a y with a question mark. Will that be the y value? Well, if you're going to graph it, it'll be the y value. Yeah, it's exactly what it'll be. If you're not going to graph it, we'll call it f at x, just an algebraic number or letter that has come out of this whole thing. Perfect. Perfect slide to talk about functions as machines. Let me do an example and then go back to that slide as promised. Let's say your function, straight from grade 9 example here, is 2x plus 3. And you decide you're going to plug in x equals 5. So you take the x equals 5 and you plug it into your machine. In it goes. And the machine goes, let me think about that for a second. And it goes, okay, f at 5 is 13. It takes the 5 and it goes, okay, 2 times 5 is 10, plus 3 is 13, f at 5 equals 13. That's what the function machine does, is it takes x values. No knocking? Did you hear knocking? Oh, maybe I'm having a stroke. That's good. It takes x values, does some work with them, and spits them out. That's what we've been doing the whole time. Whether it was parabolas, exponentials, all the way through the grades, a function just takes something, takes the input, and punches out an output. Back to here. That's what I was trying to say here. F at x means get the input, whatever the x is, put it in here, do the work on it, and whatever you get out, we'll call that f at x. Another example to try and bring that home. Right here. When you go to do your homework, you're not going to draw the whole machine and everything like that. Here's what you're going to do. You go, okay, they say the function machine is 3x plus 4. To get f values, take whatever x value, multiply by 3, and add 4. So what are you going to write? You're going to write, okay, the function is f at x equals 3x plus 4. They want f at 2. What they're saying is, not f times 2, take this function and plug 2 in to it. So I plug 2 in over here, and I just do whatever work is required there. Then you use your grade 9 bedmaster or whatever, you use your calculator, and you punch those things in. You go 3 times 2 plus 4, and you get f at 2 equals 10. Did that help? I saw frowns when I first did that. Did those examples help to go, okay, I see what you're talking about now. F at x just means plug in the x and get the y value that goes from there. Yeah? Oh, more time here? I said I wasn't going to say this. Ah, good. I said I wasn't going to say that, and then there's only one more slide, and I'm going to find out when. Oh no, breaks in the morning stayed the same. Now I'm remembering from the meeting. Breaks in the morning stayed the same. Your morning break is 10:35. We're going to make it perfectly. It's beautiful. The afternoons breaks. Well, you guys are grade 12s. I think they wanted your break to stay the same too, because they wanted you to have an extended lunch, because you guys might drive to Popeyes or do whatever. More time? We're good? One more slide. Just to recover all this, we'll always have the choice. In grade 10, you learned about parabolas, and it really came over into grade 11 as well. Okay? And we wrote y equals x squared minus 4x plus 7. Now we'll have a choice, and instead of writing it as y equals, we might write it as f at x equals. And today, you might look at it and go, are you just trying to confuse us? Is that what we're up to here now? Like, what was wrong with y equals? Nothing. You're going to see as we go through advanced functions, as you go through calculus, you're going to see there's advantages to writing it like this, is writing it as an input-output statement saying, to get f, plug in x. There's advantages to this notation. But it is enough now. It is actually enough for now when you see f at x to go, you mean y? Isn't that what you mean? And you'll do fine for the first 2 chapters of this course just thinking of it that way. When you see f at x, you go, oh, you mean the y value. Okay, I got you. And as you get more used to it, you'll see the advantage of this. Not over this. They both have advantages, okay? This will be called xy notation. This will be called function notation. Questions there? More time there? There's nothing to copy down there, right? That was just reiterating that this really is the same stuff we've been doing. We're just going to call it f at x.